This is the new chapter, and it is very interesting chapter. You all must have seen the magnet. Have you seen magnet? Yes. What property you have noticed in magnet? You must have noticed that. Yes, you must have noticed that it has the property to attract the material, the objects that is made up of what? Iron. Okay. So I hope each and every line is clear. Okay. So now let's start the magnet. So the first magnets were found from a naturally occurring mineral of iron. What is that mineral of iron called? That mineral of iron is called magnetite. So I'm underlining the important lines also. This is the new way I found to teach you. So that you all can use your book also in the class, and you can mark all the important lines in the class. Okay, and I can also explain you in a very better way, in a very elaborate way. So now let's start. So the first magnet was found from a naturally occurring mineral of iron called what? Magnetite. In between I'll ask questions also, so please answer. Don't forget to write answer. Now, so the word magnet is what? Originated from the name of town. What is the name of town? Magnesia. Yes, the name of town is Magnesia. And this Magnesia is a district in Asia Minor where large deposits of magnetite were found. Clear? So that is why the name of that material is called magnet. Okay. Natural magnets. The ore of magnetite. The ore of magnetite found in nature are called the natural magnets. They are found quite in irregular and odd shapes. So these are some characteristics, some properties of what? Natural magnets. What is that? First, you can mark it here. First, it is what? Irregular and odd shapes. And second, it is weak in strength. It is weak in strength, so they are not of much use. For practical purposes, what? Natural magnets cannot be used. Artificial magnets are used. So if the question is why natural magnets are not used to make the materials for the practical use. Clear? For the practical use, natural magnets are not used. So your answer will be what? First point, answer will be irregular and odd shapes, because natural magnets are irregular and odd shapes. And second, natural magnets are weak in strength, so they are not of what? Much. So now come to the artificial magnets. And artificial magnets are used in day-to-day life, in the practice, in practice also. Means for the practical purposes also, artificial magnets are used. So of course, artificial magnets have what? Very good properties. Means just opposite of natural magnets, you can give good shapes. Clear? And regular shapes according to your convenience, according to your use, and then they are what? Very strong also. So that is why artificial magnets are used. So the magnets that are made by man are called what? Artificial magnets. They are made of what? Iron or steel in various shapes and sizes as required for the use. Just now I have discussed here. The strength of these magnets is what? Very strong. And so these magnets are of different shapes. So according to the shape, their names are given. So now you can see here bar magnet. Means the shape is what? Bar-like. Okay. So like chocobar. When you eat, you must be liking to eat ice cream. So chocobar ice cream is there. Pista bar ice cream is there. So this bar means what? This bar means this is the shape. Clear? This type of shape is called as bar shape. So when it is used with the ice cream, it is called as chocobar. Clear? Then it is used with the pista, means if the ice cream is made up of pista, then pista bar. So and here this magnet is made in that shape. So what is the name given here? bar magnet. Next is the cylindrical magnet. Cylindrical magnet, of course, the name is very clear by the name that the shape is what? Cylindrical. Next is U-shaped magnet. Yeah, U shape. You know the shape of the U alphabet. ABCD you have studied in class LKG. So U-shaped magnet. Then the horseshoe magnet. Means the shape of this magnet is what? Like the horseshoe. Another one is this magnetic needle. Magnetic needle. Needle, you know the shape of the needle. Clear? So this magnet is in that shape. That is why the name is given magnetic needle. And this one is what? Compass. Clear? So it can move in all directions. 360 degree it can move to give the information. So these are what? These are some artificial magnets. Which one? Bar magnet, cylindrical magnet, U-shaped magnet, horseshoe magnet, magnetic needle, and compass. They are very strong. You can give shape to according to your use. Okay. So now magnetic and non-magnetic substances. So magnetic substances means what? The substances that get attracted by magnets are called as what? Magnetic substances. Okay. So the substances that get attracted by a magnet are called magnetic substances. And what are the examples of the magnetic substances? Yes, iron, steel, cobalt, nickel. They are what? They are magnetic substances. Okay. Then what is non-magnetic substances? Just opposite of what? Magnetic substance. Yes. So the substances that do not get attracted by magnet. Yes. The substances that do not get attracted by a magnet are called non-magnetic substances. For example, wood, plastic, copper, paper, aluminium, stone. Yes. So this you can do at home also. If you have magnet, you bring the magnet to the table which is made up of wood, or simple this pencil. This is a pencil, no? You bring the magnet to this pencil. You will see that this pencil is not getting attracted by magnet. This pencil is what? Yes, this pencil is the example of a non-magnetic substance because this pencil is made up of what? Wood. Yes, so this is wooden pencil. Some pencils are there in that only the lid is used. That is made up of what? Steel. That can get attracted. But this pencil that I am using, such type of pencils do not get attracted by a magnet because it is made up of wood. And wood is what? Non-magnetic substances. Okay. So iron, cobalt, and nickel, they are what? They are the magnetic substances. Copper, paper, plastic, wood, stone, they are what? They are the non-magnetic substances. Now, so the characteristics of the magnet. Now we will discuss about the characteristics of what? Now we will discuss about the characteristics of a magnet. So what is the characteristics? First, when a magnet is suspended freely, what happens? When a magnet is suspended freely, it always rests in which direction? North, south direction. So instead of here, it is given here. It is written in blue color. So when a magnet is suspended freely, it always rests in north-south direction. So instead of this in a specific direction, you will write what? North-south direction. So when a magnet is suspended freely, it always rests in north-south direction. This is only important. Okay. Now next, north-south direction means when you suspend the magnet, then what? The end of the magnet which points towards the geographic north. Please mention the word here geographic. It is not mentioned here. Here, this is wrong. Correct definition I am giving you here. So please note down in your book. The end of the magnet which points towards the geographic north is called what? North pole. Okay. So please cancel these words. Unnecessary words given in between. No need of this. I'm just simplifying you. Clear? Yes. So the line that is given here is not very correct. So I'm just simplifying. Means I'm telling you to make the line simple so that it becomes very easy to learn. Okay. So here the end of the magnet which points towards the geographic north is called North Pole. So what is North Pole? Yes. magnet which points towards the geographic north is called North Pole. And what is South Pole? Again you will write. Please write down there in the book. The end of the magnet. Yes, some words are missing here. Students, some words are missing here. So please write down in the book. The end of the magnet which points towards the geographic south is called South Pole. Yes, and North and South poles are marked by capital M and capital S respectively. Means North Pole is marked by capital M and South Pole is marked by capital S. Okay. Now, second characteristics of magnet is that a magnet attracts the small pieces of iron. Yes. Magnets always attract the small pieces of iron. So you can see here also in the diagram, it is very clear. Attraction is when you will bring common iron pins close to the magnet. What will happen? The iron pins will get attracted towards the magnet. Yeah, this is the first thing you notice. Second thing that you will notice is what? You will see that the maximum iron pins are getting attracted at the poles. Yeah. They are attracted what? At the ends of the magnet, at the poles of the magnet. Very few pins you will get in between. So this shows, this indicates what? That means the maximum attraction in the magnet lies where? Yes, at its poles. So the ends of the magnet where the attraction property, where the attraction property is maximum, they are called as magnetic poles of the magnet. And in the magnet, two poles are there, North Pole and South Pole. Okay. Now, next is like poles repel and unlike poles attract. This is very clear. When you bring two magnets close to each other means what? Like if two bar magnets, here you can see. You can see here. So when you will bring two bar magnets close to each other with the same pole, here North Pole is brought near to the North Pole. So you will find what? The repulsion here. Yeah. But when the pole is changed, the South Pole is when you bring South Pole close to the North Pole, then you will find that the attraction is there. Both the magnets want to come too close to each other. So this indicates that like poles of magnet repel each other and unlike poles of magnet attract each other. Yes. But one more thing is very important here, that which test is the sure test to check the magnetism, attraction or repulsion? Repulsion. Repulsion is the sure test to test the presence of a magnet. Check whether the substance is magnetic or non-magnetic. Because attraction, please all of you focus very nicely. Attraction can occur between the magnet and iron pins also. But attraction cannot be between two magnets with the same pole. Okay? Once again, attraction can be between the magnet and iron pins, but attraction cannot be between two magnets when their poles are same. Clear? So that is why check the two substances given to you to check whether they are magnet or not. Then what? You can check it through which test? Repulsion. Because attraction occurs between the two magnets when their poles are different. Yes, when their poles are different. And attraction also occurs between the magnet and the iron pins. But repulsion only occurs between the two magnets when their poles are what? Same. So repulsion is the sure test to check the magnet. Yes? Now, poles exist in what? Pairs. Always. When you suppose this is the magnet. This is the magnet. This one is what? This one will be North Pole. This one will be the South Pole. When you break the make the magnet. This is small piece. Suppose this much is the broken part. So in this broken part also you will find the North Pole and the South Pole. Here, again you break it. Suppose this much length of the magnet got. Then in this small length also you will get the North Pole and what? South Pole. So that is why we can say that poles exist in pairs. So magnetic poles always exist in pairs. Okay, nothing is important here. What is important that I have explained, and only this line is important, that magnetic poles always exist in pairs. And how it exists in pairs, I have explained you. I hope this explanation has become clear to all my students. Okay, now next is now I'm going to discuss the all properties that we have discussed till now about the magnet. So the first property that we have discussed is what? Yes, here you can mark. This is important. A magnet attracts the small pieces of iron. Okay. Second, a magnet always rests in which direction? North-south direction. And third, that like poles repel each other and unlike poles attract each other. Okay. And fourth, poles always exist in what? Pairs. So these are the four properties of magnet. What is the first property? See, please write. Yes, a magnet attracts the small pieces of iron. Second, magnet always rests in which direction? North-south direction. And third, like poles repel each other and unlike poles attract each other. And fourth, poles always exist in what? Okay. Now, next, magnetic field around a magnet. So the space around a magnet in which if magnetic substance such as small pieces of iron are placed, they get attracted towards the magnet. And this place, that place is called as what? Magnetic field. For example, like when you keep your magnet here and you are keeping the iron pins around this, what will happen? All the iron pins will go. All the iron pins will get attracted. Okay. But if I keep magnet here, you can also do. If you keep your magnet in front of you and you keep the iron substance out of your house, what will happen? Do you think that those iron pins will get attracted towards this magnet? No, it will not be attracted towards this magnet. Why? Because because as the distance increases, the power of the magnetic field decreases. It means what? Simple way to understand that you can handle the things around you. You can handle the things around you. If something is going wrong, you can check. Okay. But if something is not happening in your house, something is happening outside, can you control that? Can you control those persons? No, you cannot control. Why? Because this is what? That is beyond your, because that is beyond your field. Okay. So same thing happens with the magnet also. Magnet also creates its power. It spreads its power around itself. Clear? And the place where its power works, that place is called as what? Magnetic field. Okay. So you can see here, this is the north and south pole, and this is the magnetic field. So, and when iron fillings are kept on a sheet about the magnet, it gets arranged like this. So you can do that also. It is very interesting. Yes. So now, Earth's magnetic field. So Earth itself behaves like a magnet, and it has a magnetic field around it. In a limited space, the magnetic field of Earth is same everywhere, and is in direction from geographic south to geographic north. So Earth itself is a very big magnet. It doesn't mean that below the Earth magnets are there. It is not because of that. Because the Earth has the power to attract all the objects towards itself.
has the power to attract all the objects towards it, and this property is called as what? This property is called as magnetic. Clear? This magnetism. So we can say that Earth is also behave like a good magnet, and so if Earth is magnet means there is a field around the Earth that can attract the objects. So, but in space, where is Earth? You know, in the solar system where Earth exists. Clear? So, if beyond that field, if things are there, then that will not get attracted towards the towards the Earth, and that is why all in solar system the other also move in what on their own path. Clear? They move as the Earth moves around the Earth revolves around the same Earth, sorry, Sun. Same way, other planets also revolve around the Sun. They are not getting attracted towards the Earth. Yes. So, Earth behaves like a magnet. Now, next is the recognition of Earth's magnetic field. If we suspend a magnet such that it is free to swing, we see that it always rests in which direction? North-south direction. And the north pole of the magnet lies in what? Nordic north direction. And south pole of the magnet lies in what? Nordic south direction. Yeah. So, this is not so important. The main important thing is that Earth is a magnet, and there is a magnetic field around the Earth. It also behaves like a magnet as the simple magnet behaves. Okay. Now, next is next topic I will discuss in the next class. Till then, you all please learn till where I have taught, because next class I will ask questions also. Okay. So till now, which your topic I have discussed? You go through it very nicely. Yes. If you get problem to understand, you see the video again and again, so that all the topics, all these points become clear to you.